Hello, everyone. I'm Mike Heroux. I'm one of the organizers of the 2021 Collegeville Workshop on scientific software with an emphasis on software teams. In this interview, I have Han Yong Wunrow, who is an intern at Sandia National Laboratories and is in between grad school gigs, with the University of Washington, having just finished up there, right, Han Yong?
Yes.
And heading to Columbia University, so on the opposite coast. Are you actually moving geographically? Are you going to be living?
Yeah, about in a month or so, I'll move out to the East Coast.
All right, very good, very good. Han Yong is here talking today with us about his white paper contribution to the Collegeville Workshop on data-driven approaches for software teams. Han Yong, maybe I'll let you do some introduction of yourself, a little bit deeper background, and get into the thesis of the paper that you submitted. So go ahead,
Right.
take it away.
Sounds good. Well, thanks again, Mike, for having me.
Yeah,
So again, my name is Han Yong Wunrow. I'm, I guess, a current intern here at Sandia National Laboratories on the PSIP team, which stands for Productivity and Sustainability Improvement Planning. My background is in applied mathematics for both my master's and my PhD that I'm about to start in this fall. And I guess the main idea of our white paper is that there are certain characteristics of team interactions that can be captured with data-driven modeling. So one of the techniques that we bring up is network science, and one of the characteristics that we can extract using network science is, for example, community structure. And I guess the idea there is hopefully that there's a relationship between these characteristics and the software artifact that those teams produce that might be generalizable and can help inform practices to sustain teams' health and, I guess, success of those teams.
Very good. So in order to have a network, you have to have nodes and edges. What's an example? I think the nodes are the team members, right? Mm-hmm. How do you develop edges between the nodes in the graph?
Yeah, that's a great question, and is also like kind of, although it's network science, it's also kind of an art, because you want to create these like certain edge relationships that are meaningful and you can extract useful information from. So one example is looking in, I guess, code repositories. People who use Git, they make certain commits to a certain set of files. They also use pull requests, other types of interactions like that. And now that, I guess, scientific collaborations have grown to such a large scale, there's kind of a real opportunity for empirical software science to, I guess, extract that commit data to create those edge relationships. So more specifically, you can look at, I guess, person A, person B, they both commit and make changes to the same file. And then you can count those number of commits or kind of create a certain quality metric to measure those commits to see how closely related or how closely those two people interact with each other, and then create that for all of your members of your teams or across multiple teams who work across different projects together.
Yeah, very good, very good, very good. Can you maybe say a little bit about how you got interested in this particular topic? You have an applied math background, and so you're taking your mathematical training and applying it to this particular problem, right?
Definitely. So yeah, I wouldn't say that I'm the person who came up with this specific idea. As an intern, I kind of was brought onto this project, but they did have me kind of interview with a couple potential teams, and I thought this, I guess, certain projects fit definitely with my background in applied mathematics. I didn't bring this up, but during my master's at the University of Washington, I actually worked in global health research, where there are like kind of applications of network science kind of looking at disease transmission. So I did have a little bit of background in kind of modeling interactions using networks. And I think that's one of the kind of real strengths of using networks to model different things, is because it kind of spans multiple different science domains. Everything, for example, here looking at relationships of software or scientific software teams, all the way to, again, looking at disease dynamics, also social networks. And I think there's a lot of knowledge that was kind of obtained looking at other scientific domains that can be applied here also to researching how teams interact.
Yeah, very good. So I know that this is a pretty new topic for you, but have you come up with any interesting insights, some observations that you said, wow, that's interesting?
Yeah, I guess one specific unique part that I've been looking into is just looking at the temporal aspect of networks. So of course, projects span like 5-10 years. And for example, that one example where I'm talking about co-file commits of how people interact, maybe someone at the beginning of the project, I guess, committed to a certain file, but then like 3 years later, a different person committed. And you have to kind of treat like, oh, did those two people actually commit together or not? Or maybe you should separate that. So within network science, there's kind of techniques for you to segment these different time slices. So you have kind of the same idea of networks, maybe common kind of actors between each slice, but you talk about maybe from this quarter year to the next quarter year to the following quarter year, and where you kind of can separate those networks, so you're not talking about a person in year 1 interacting with a person in year 4, but just in between those kind of closely related time slices instead. And I think that's something that we don't really have results on, but I think something that can bring a lot of value to analyzing teams, especially if you incorporate this temporal aspect.
Yeah, very good, very good. Well, thank you. Any other final comments you want to make before we sign off?
Yeah, I do want to, like, although like kind of the main point is kind of promoting this idea of data-driven approaches, there are lots of limitations that you should consider when using data-driven approaches. So first of all, of course, you want to consider the quality of the data, although there's like methods you can use to kind of measure uncertainty in your results. If you're starting with poor quality, you're going to get potentially poor results or not very conclusive results that you might not be able to act on. And it's also important to kind of incorporate also like subject matter experts specifically on the I guess research topic at hand. So empirical software science is a relatively new field, but other social scientists have been studying teams for quite a long time, and I think can bring a lot of value by asking them for their insights on researching scientific teams or scientific software teams.
Yeah, very good. Well, thank you. It's been a pleasure chatting with you, Han Yong, and I wish you well in your continued graduate studies next year. Thank you very much for your contribution to the workshop, and hopefully we'll have some interactions when we are live next week, June 20th through June 22nd. So thank you very much.
Yeah, thank you as well. Bye.